In calculus, there are some basic log properties that, if you know well, are going to be really beneficial when you start trying to take the derivative of any problems, including the natural log or exponential functions. So here are the three that tend to be the most helpful. Number one, if you take the log of a product, you can separate those through addition by taking the natural log or the regular log, log base 10 or log base anything, of the two separately and adding them together. So the natural log of the product A times B is the same as the natural log of A plus the natural log of B. Now, how you've probably seen that before is log base 10, which works exactly the same. The reason that in this problem I'm going to be showing you that with the natural log is because we in Calc Concepts only use the derivative of the natural log, and so that's where we'll focus our log properties. Now in the second one, I've got the natural log of A divided by B. Now using our log properties, we can rewrite that as the natural log of A minus the natural log of B. So in summary, if you're taking the natural log of a quotient, we can separate that as the natural log of the numerator minus the natural log of the denominator. Now finally, I would say the most helpful one in my opinion is the fact that when we take the log of something being raised to a power, that's like our Super Mario Brothers knockdown that lets that x come out front, and it levels the playing field for us so we're better able to take the derivative. Now let's look at how we can utilize some of these properties in practice. On our first example, where we are solving for x, we have the natural log of x squared is equal to 3. Now it's hard to solve for x squared when it's in this form, and I want to try and isolate this and get it by itself. One way to do that would be to put it in exponential form versus log form. The natural log is base e, and the answer is the exponent. So I can rewrite it as e to the 3 is equal to x squared. Now, e to the 3 may look intimidating, but that's just a value. Specifically, it's equal to 20.09 if I round to the hundredths place. And then taking the square root of both sides, I get x is equal to plus or minus 4.48, knowing that it can be a negative number because when I plug it back in, I'll square it, which will give me a positive. Now, in our second problem, where we are again solving for x, it's looking like it's going to take a few steps to get us there. Now, we can utilize quite a few log properties to help us. First of all, anytime you have a coefficient out front of a log, you can bring that back in and put it as the exponent. So I can rewrite this as the natural log of x cubed minus the natural log of x squared equals 5. Now, my reason for doing that is because I want to get all my x's together, and I can now use another property of logs to combine those. Knowing that when we are subtracting two separate logs, we can combine those through division. So this would be the same as the natural log of x cubed over x squared is equal to 5. Now we're able to simplify that, so natural log of x is equal to 5. So now if we want to solve for x, because that's what we're being asked to do, we can rewrite it in exponent form. So that would be e to the 5, because this is base e, is equal to x. So utilizing my calculator, I can take e to the power of 5, and I would get x is equal to 148.41.